Have our centralized versus decentralized ventilation systems with Eric Fino from Small Planet Supply. A little bit about 3C Run before we get started. We ask that everybody make sure they are on mute throughout the duration of the course, and if you would like to verbally participate, please raise your hand in the participants section and we will call on you to unmute yourself. We encourage people to also ask questions in the chat, and we'll get to those questions during break times or at the end of the training session. Next slide, please. A little bit about 3C Run. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. We work on improving energy efficiency in our region by offering free programs and services for building professionals and households. 3C Run is funded by ratepayer dollars, which are collected through the public's good charge found in our utility bills. The benefit of being a ratepayer funded is that there is no cost to those we serve, and all our trainings are free. And currently we have 3 programs. Next slide, please. Energy Code Connect is the first one I'll be talking about. We offer industry trainings, regional forums, and Title 24 consultation services called Energy Code Coach to help building professionals navigate the California Energy Code and grid building requirements. The phone listed on the slide is our Energy Code Coach hotline, and there's an inquiry form on our website. Building performance training. This program, we offer trainings on technical and soft skills related to building science principles and systems for high performance building. And our goal is to bring industry recognized certifications and training providers to the Central Coast. And last but not least, our home energy savings program. We offer households incentives and just looking to make energy efficiency or electrification upgrades possible for this region. And with that being said, I'll hand it over to Eric to get us started for the day. Thank you.
Trying to find my unmute, sorry. Welcome everyone. I am getting over kind of a bug, so if I sound a little gross, I'm sorry. Nice thing about Zoom, your antivirus probably has you protected there. But welcome to central versus decentral ventilation. And we're going to go over a few things today, starting with some context for why the systems exist in the first place. This is something that is still new for a lot of people. There's a lot of folks who it's something that is kind of a recent topic, at least how much it gets talked about. People don't really understand why it's so important, especially 20 years ago, we really didn't talk about it at all. So kind of a refresher on why there's a focus on it now, why we're moving towards these systems, and what we're trying to accomplish overall with a ventilation system specifically. And then we're going to talk about central and decentral, sort of the categories, how they work, how they're different, how they overlap, right? And where you might pick one over the other. We'll cover both. I am going to spend a little bit more time or get a little more in depth with decentral. It's not new, but it is something that's definitely less implemented. It's not quite as familiar as systems that incorporate ductwork. We will talk all about it. If I can, there we go. Nobody ever in the history of cool cars has said, hey, cool Ferrari, can I see the radiator? Right, but it still has one. It's still a vital part of that car's ecosystem. It would be way less fun to work or way less fun to drive if it worked at all, if it didn't have a radiator, right? And ventilation for a house is kind of in that vein. Will anybody ever want to see it? No, unless they're a nerd like me. If you don't have one, will you have a problem? Then yeah, absolutely. It is the dental hygiene of the building industry. It's really important. It's not super exciting. Um, so, forgive me if you've listened to me talk about ventilation before, because I do go over this stuff in all of my presentations. Um, but again, it's something that's not really in the public consciousness quite as much. And so it's got a knowledge gap. And I try to talk about this stuff every time I do one of these. Um, so quick recap on why we ventilate and why ventilation might not be something that you've really considered before or had to think about before. Um, we've been managing air in our buildings as long as we've been building them. The difference now is that we really want to control that air movement. In the past, we essentially were managing it by creating pathways in our building envelope for it to just sort of passively move through and relying on things like wind or convection to move it around in the house. Um, and my favorite analogy for this is the kind of thermos versus colander, right? So they're both meant to interact with hot liquids, but in different ways for different purposes, right? And similarly, the way we build now just thinks about stuff like thermal performance and air movement in a way that is fundamentally different than we would have in 1920. We don't have different priorities exactly, but the list is a lot longer and we think a lot harder about stuff. um, the priority for kind of the colander, if you will, the naturally ventilated house was really just it needed to be durable. We wanted it to stay up, and we wanted to keep the rain off of our heads. We had really good lumber back then. We didn't worry so much about or even know about contaminants from stuff like smoke or pollen or pollution. People were generally a lot more willing and used to being kind of cold or uncomfortable. It's humid, dry, whatever. Um, they really wanted something that was going to stand up and be a good shelter, and if you needed a large energy input, that's okay. It's just that's what it was. It's not like there was anything better. um, and it worked out pretty well. um, Basically they would build intentionally what we would now call a leaky envelope. um, and insulation really wasn't common until the second half of the 20th century, because people knew that the air that they were moving through that envelope would cause condensation, and that's where they would see durability issues with this system. Um, if you didn't have insulation, there wasn't a condensing surface in there, and it wasn't usually an issue. Often it would condense on windows and stuff, but your timber would be okay. Um, and so they didn't insulate them. All right. And basically we got what we wanted with this. They just needed a ton of energy input to keep stuff conditioned. And even, 40 years ago, 2,000 square foot house was like a 5 ton heat load. Uh, Whereas now, if you look at modern construction, that's probably more like a 18,000 to 24,000 BTUs, right? A ton and a half to 2 tons. Um, these houses were really nice. You could do some beautiful work with them. Um, the house pictured here is my mom's house. It's a kit house from 1912. They ordered this in the mail and built it on site. It's got a great view. It's got hardwood floors. It's got original timber. But you can pour a cup of coffee through the floorboards into the basement, right? You can tell it's windy outside in a room with no windows. Um, it's done what it's supposed to do. It's just not great at what we probably would want it to do now. So mercifully, our list of priorities has kind of grown, as have the materials and the systems we have available to us. And so really, we would like to be comfortable above all else, I would say, when we look at houses. We're well insulated now. We're thermally efficient. We're airtight, so it's not drafty, and we're not losing thermal efficiency to air moving through our envelope. And we're eliminating those condensation concerns with our insulation that we definitely want now. Um, this gives us a building that's still resilient and also thermally efficient if it's ventilated right. It's more comfortable and efficient if it's ventilated right. If it's not ventilated right, then you end up with air quality issues, right? That's not a problem we used to face with the naturally ventilated buildings, right? That's why they naturally ventilated them. Um, Now that we are building in such a way that we're prioritizing energy input and comfort like this, it's not really optional anymore. We've just sort of neglected it. And I've talked to a bunch of really high-end builders who, and they all have a horror story about, I worked on a multi-million-dollar project. It was gorgeous. It won awards. It was on magazine covers. And they had to go back a couple months after somebody moved in because it very quickly developed unacceptable air quality issues because ventilation's not optional anymore. Um, that wasn't to begin with, but you really have to think about it now. So most of the projects that I personally deal with, we would call high performance. So they're sort of beyond code, right? I deal with a lot of passive house stuff, FIAS, net zero. Um, and I always like to ask, why did you go that route? What did you want to get out of this? Um, and I'm always kind of surprised when I look at how frequently I get certain answers because number one is I want to be comfortable. And then that's followed pretty closely by energy efficiency. I want lower bills. I'm building off grid. I think the energy infrastructure in my area isn't great. Um, there's also a lot of sentiment around value, right? You have to be good at building things to build a house that performs well. So you get a quality product that's more durable and more comfortable when you go that route. And interestingly, climate concerns are on the list, right? That's probably number four. Um, but I always think of that as being the big driver for people, and it at least right away when I ask, it's not. It's usually kind of far down there. But what you'll notice about this list, and the reason I bring it up, is that there's not really any curveballs in it. Except climate concern is sort of a niche thing. Um, Maybe should be less of a niche thing, but um, there's nothing about comfort or energy efficiency or value that anybody building or buying a home would say no to. That's what we want in every home, and it always has been. So building this way does it better. You just have to ventilate it and make sure you're managing some of the new challenges that building that way presents. Um, and so this is kind of a reference point for my next two slides. So these are just ranges for indoor contaminants that we would want to see. This chart I picked because it was kind of the nicest looking one. A couple of these guidelines are kind of low. For CO2, I would normally say 800 to 1,000 is kind of where you would want to cap out. They've got like 300 to 800, which is pretty low. Um, 800 to 1,000 is really where we go. Yeah, that's objectively bad. Um, for humidity, most people are comfortable between 30 and 60 instead of 40 and 60, although 40, you kind of see both sometimes, but that's also more or less the range you want to be in to prevent microbial issues and things like that. But that said, right, this is why we ventilate. You can see right away that fine particles are a health concern, and if you've got a central ventilation system, it's a really nice opportunity to put a high level filter in and keep those particles out. Um, and then CO2 and humidity, we manage those by diluting them with a supply of fresh air, and we cycle our air out and do an exchange. Usually it's once every 3 hours, so call it a third of an air change an hour. We're consistently exchanging that air so that we don't get buildup. And in addition to, there's some health concerns listed here, um, which could be, mild as just something that's kind of annoying. I'm allergic to cats. I have cats. I live with it. It's fine. I like cats. But there are also things that could be really severe, right? I talk to people every once in a while who have really serious medical conditions, and It becomes something that like they might have to get hospitalized for if it's not being managed well. Um, there's also kind of a quality of life factor to it. So overwhelmingly, what you hear about poorly ventilated homes is that they just kind of smell bad. There's an odor, they're clammy, they're dry, they have mildewy bathrooms, and that's because these factors aren't being managed right. Um, so what happens if you don't ventilate a normal, I call normal. This actually is below normal for what we're building now. This is probably an older house, but I always like to include this slide. If you've seen me present this before, maybe you've seen this. Um, this is almost a direct analog for my own home, for my bedroom, and we'll look at that later on. This is not my home, but it's very much what I experience. So again, this is not what we would call an airtight house. So we've got a blower door score of 5 air changes an hour at 50 pascals. Um, and just for reference, code built construction, excuse me, has been averaging about 4 air changes an hour since the late 90s, right? Since about 98. Um, and so, what happens even if in this not so airtight home when we don't have ventilation? Oh, I skipped. There we go. So even in this situation, we end up where well, I guess the scenario here is we've got a bedroom and two people are going to sleep. They close their bedroom door and the fan in the adjoining bathroom is not on. So there's just no ventilation in this area. There's no air movement. And within 45 minutes of going to bed, they're over 1,000 parts per million. And then around 1:30, somebody gets up, they turn the bath fan on, we're still going up, right? So we're not getting dilution, we're getting a little bit of exhaust, and it's pulling air under the door, but it's not doing quite enough. We're still going up in this case until right about 6:30, somebody wakes up and they open the door, and we get that dilution, and our CO2 goes way down. Um, And then there's another little drop here. I don't know if that's somebody making breakfast or leaving for work and opening the front door. Um, those big changes in volume do go a long way for um, changing your local CO2 levels. But the what I'm trying to illustrate here is that, you know, even 20 or 30 years ago, houses were being built sufficiently airtight to necessitate these measures. Um, right, my own home included is 2005, and I have ventilation and air quality issues. It's just something that it's not something we haven't needed. It's something that we've been neglecting. Um, and when we look at modern construction, um, right? How do contaminants work in that situation? Well, as you might imagine, um, it's a little bit more serious. So this is an example of a tight home, right? Built on Monterey Peninsula. This was built in 2016 to be a healthy home. And so they took really great care in selecting materials and finishes that are going to off-gas harmful chemicals, paint smell, stuff like that. We call those VOCs, volatile organic compounds. And there's different levels for each compound of how serious it is and at what levels are going to be hazardous. Um, but generally speaking, it's annoying at the best and can be unhealthy at the worst. So this is a best case scenario in terms of a building with VOC in it, and still uh, they wound up in a situation where they had issues. Um, so with the ventilation system turned off and the home closed up, so nobody going in or out, over about 2 days they spiked from this very low level way past our threshold here up to about 3 times what we would really want to see. And that peak is like I said, it's better than most homes would be experiencing today. If you don't have a ventilation system, um, this is not a this is something where you need to open your windows and lose all of your heat. if you want it to go away. Very much this is what building a home to today's standards will look like, if not, if those homes aren't worse because they're not paying quite as much attention to what they're putting into them. Once we turn our ventilation system back on, it dropped right back down, right? We're getting our dilution, we're turning over the air on a regular basis, and are well within a healthy range. Um, so that's kind of what happens if you're not ventilating your house, your project properly. Um, so here is a question that I do get from time to time. What if I did just open a window? What if I got a whole house fan? My climate's not that cold, it's not that hot. Maybe I could just put in ductwork and still have like a passive wind-driven system, or I can use a mechanical fan that's not conditioning anything, it's just exchanging. And we've already discussed a lot of this, and maybe you have an idea of why this would not be great. People do this. It does not spectacular. Um, it's kind of one of those things where I go, why would you? Um, just building to code, you're probably 80 or 90% of the way there already. Just go the extra 10, 20%, and don't have the problems. And a lot of the time, this is not like an indignant thing. It's not like a spite-driven thing. People just don't know that there's different options out there. Um, but really trying to take a modern house and use that passive air movement strategy, or use something that's not recovering any heat, is kind of shooting yourself in the foot. You're spending the money, you're doing the work, don't get less for it, right? And even if you're in one of those mild climates, it's going to be 50 degrees outside sometimes. You're limiting your opportunities to do an air exchange, because you don't want to fill your house with 50-degree air. Um, you're Even if your conditioning system eventually keeps up with it, you're still going to be cold for a couple hours. Um, so there are cases which we'll talk about where you do need to present a pathway for air to move. We call that a makeup air. I'll talk a little bit about that later. But generally speaking, if you do this, you're working just as hard to get less. Um, Instead, we would use a recovery ventilation, and this is kind of why you're accomplishing less with those solutions. So instead of just naked holes in the envelope, uh, connect them to a heat exchanger and give that heat exchanger a couple of balanced fans, and we have solved all of those problems. It's one extra component. Um, it's just the better way to go. We have a really easy place to put a high level filter in. It is going to manage your air quality continuously. It takes that uncontrolled variable and it controls it. And it's just one extra piece. It's a little extra work. You got to think about it a little bit more, but it works so much better. Just go the extra 10%. Um, I'm assuming you know what an HRV is since you're here. If not, this is it. It's basically a heat exchanger with a couple of fans on it. Efficiency on these can range pretty widely. The one in the picture here is a central system, but the efficiency statement is true also of decentral systems. They can be down in the 50% range, which I would probably advise against, or they can be up in the 90, sometimes 95% efficiency. So that means if you're bringing in, you know, for sake of easy math, if you're bringing in 100-degree air, um, then you're going to get 95 degrees on your um, cold side. So it's gonna exchange 95% of the heat, to the side that you really want it to be on. Um, and sometimes that's your outgoing air, sometimes that's your incoming air. If it's cold outside, you want your incoming air to be warm. If it's warm outside and you're cooling your house, you want your incoming air to be cool. It works both directions. You might also have heard the term ERV. That's basically the same thing. It just also has an added ability to resist big changes in humidity. And where you would pick one over the other is really a climate-driven thing. Um, if you're in an area like the American South or the Southwest, you'd probably want an ERV. Pacific Coast, often you'll want an HRV, but sometimes you can do both. Um, and if you have questions about that, you give me a call whenever. I would be happy to tell you probably what's going to work best in your area. Um, oh, sorry, I've got a little bit of a delay in my button pressing. So in both central and decentral systems, we want a balanced ventilation system. So balanced ventilation is simply supplying and exhausting air in equal measures. So ideally, we have a unit that can self-balance, especially if we're using stuff like bath fans or something like that to help us with bathroom management. Um, that's pretty common in decentral systems. It's less common in central systems. Um, and self-balancing is where the unit will detect a pressure imbalance between its supply and exhaust channels, and it will attempt to equalize the flow through it either by turning a fan up or ramping one down as the situation calls for, enough to keep the air moving across the heat exchanger in closer to equal volumes. So there's a couple of reasons for balancing and having balanced ventilation. In terms of efficiency, we want the maximum heat transfer between our conditioned stale air that we're exhausting and the unconditioned fresh air that we're bringing in. And there's a time component to that exchange. If one air stream is moving faster than the other, doesn't really matter which one, we have less exposure time and our efficiency goes down. The other big one is pressure. And so this kind of goes back to what I was talking about with the insulation and natural ventilation. Um, there's positive pressure where you're supplying more than you're extracting. There's really only one situation there's a lot of cases where people say you might want it. There's really only one that I sort of blanket agree with. Everything is kind of case by case, but in general, the only time I don't look really hard at positive pressure is if you have a fireplace or some other source of combustion inside the house. Um, a positive bias helps us make sure that we are getting those combustion exhausts out the way they're supposed to go and not pulling them back into the house. Usually the stack effect in your exhaust vent or your chimney is going to be enough anyway, but it's just a little, it just helps. Um, a neat resource for pressure, if you want to learn more, is this. They call this the House of Pressure. The center picture here. The Building Performance Institute in Bellingham has built this little working model. I got to go play with it once, but they've got a couple of YouTube videos about it. It's worth checking out because it really does show you sort of how changing your indoor air volume, like by opening doors, like we saw with the CO2 graph, how that affects the way air moves around in your house and where problem areas might be. Um, Negative pressure, where we would be exhausting more air than we would be bringing in, is one of those ideally never, realistically sometimes things. You will have it one way or another if you're using bath fans or a range hood. Um, it often is not something that we can avoid. That's why you would have that makeup air system where you're creating a channel for air to be brought in just sort of via pressure differential. Um, you just want to control where that air comes in by giving it a pathway instead of making it find holes in your building envelope and creating potential condensate concerns. Um, that's also why self-balancing is really nice in a ventilation unit, because it can help, if not completely overcome those. But in both cases, pressurization is going to introduce air movement across our thermal envelope, with the exception of the fireplace scenario. It's just something we want to avoid. It's not the end of the world, but just mitigate it where you can. Don't do it intentionally, except, again, fireplace. And the way we avoid it is by planning. So you can see on the left here, we've got an air schedule. So this is for a central system. We figured out the air we need in each room. This is driven by code. So bathrooms, you'll need at least 20 CFM extract. Um, the supply side, generally, code doesn't dictate that much. We tend to put kind of 30 CFM in bedrooms that are going to be occupied by two people, maybe 10 in less used areas, 20 to 30 in a living room. Um, there's a few resources to help you figure that out, but bathrooms need to be 20 CFM. A bathroom is a room with a toilet in it, by code most places. That often ends up driving kind of how you design these. But ultimately, what we want is for these two channels to be the same, to have the same total number, the same total flow. Um, and that's one reason there's something called commissioning, that's really important for central systems. Um, Ductwork adds a lot of complexity, and units don't know what they're delivering at the diffuser. They know what's moving through the unit. So going around and verifying your airflow and adjusting things, to make sure you're actually getting these numbers is really imperative, especially if you are replacing your bath fans, which you can do, but you have to make sure you're getting that 20 CFM. And it also helps us with efficiency, making sure we're not pressurizing things or depressurizing anything. With central systems, I highly recommend commissioning, whether it's you, your installer. Um, Having somebody verify and tune things goes a long way for the performance of those systems. Um, in decentral systems, especially, sometimes in central systems too, maybe you have bath fans. And I've talked a little bit about this. There's a little bit of animosity in the high performance community about bath fans, and especially using HRVs to accommodate them. HRVs are not makeup air systems. And all of that is correct. On paper, I agree. That said, it is something that people sometimes call me about, um, and are a little panicked about. Um, my This might be my hot take. Um, I don't really worry about them. If you have to use them, you have to use them. I try to be realistic and practical. Usually a bath fan is like 80 CFM. It's not great, right? If you don't have to, then maybe don't. But if you have to, it's not the end of the world. Usually an HRV can accommodate that. Range hoods are a different story. If your range hood has a higher operating capacity than your HRV, and spoiler alert, it almost certainly does, you need a makeup air for that. Your unit's not going to be able to supply enough air or allow enough air to be pulled through it for that to not cause a big depressurization of your house. Um, so you do need to account for that, with the possible exception of like a makeup or a microwave range hood. Generally, those aren't super great at being range hoods. They're usually like 80 to 150 CFM. They never do what they're rated for. Um, you can usually pull that through a unit okay. But your stainless steel 800 CFM monster range hood, not going to do it. Get a makeup air. Um, when we ventilate with a central or a decentral system, this is really what we're trying to accomplish. This is what we want to get out of it, the way we want to manage our air in our home. Air moves by pressure gradient. So if you have a high pressure, the air moves away from it. If you have a lower pressure, air moves towards it. And we can use that to control our air quality and control where the air goes. So typically we would supply air to places like bedrooms, living spaces. People are going to be there in those areas, spending time creating CO2 and moisture that we want to dilute. So we add air into those rooms. And then in our bathrooms, in our laundry rooms, our kitchen, we have moisture concerns. We have maybe VOCs from, say you have like a range or even just cooking. Um, we have stuff in those areas that we want to remove and also don't want to backdraft into the rest of the house. So we put our negative pressures in those areas, and the air pulls via that pressure gradient from our supply regions to those exhaust regions and exits. That's a little bit easier to do with a central system than a decentral system because you do have a little bit finer control. But ultimately, that's kind of what we're wanting to do with both of these sort of categories. And then because we're balanced, right? We're supplying and extracting in our equal volumes, even though locally these regions are pressurized. Your house as a whole, your building envelope does not have a big pressure difference between it and the outside. So just a quick pause. Sorry if that wasn't news to you. Hopefully you learned something from that. Um, but are there any questions so far? And then we'll get on to central ventilation. Let's see. Where is the questions tab? Well, hopefully not, because I can't seem to find where that is. Oh, okay, there's a chat. In Seattle, HRV or ERV could be either. I'm seeing a lot of people ask for ERVs now. I'm in Olympia. We've been having a lot of summer and winter conditions where winter, it's always been kind of humid here, but the last couple of years in the summer, it's been really muggy. Um, and I have seen people asking more for ERVs because they do help resist outdoor humidity conditions. They're not a dehumidifier, but they're a little bit better for that. Um, so it could be either. Normally, we would recommend an HRV. They tend to be a little bit cheaper. Nominally, they have a little bit higher efficiency. But if you are regularly uncomfortable when you go outside and it's not because it's hot or cold, it's a humidity thing, then you probably would benefit from an ERV. There's not really a wrong answer. It's just, you know, if you're not that uncomfortable with your humidity levels, an HRV will be cheaper. Um, what is the maintenance on these systems? Generally, it's just a filter change. Um, and then sometimes there's a core cleaning where you clean that heat exchanger. Um, so you would usually change your filters every 3 to 6 months. You would clean that core out maybe every year or two. Um, HRV or ERVs in Montana and high desert, ERV for both of them. If it's really cold and really dry, it's an ERV. Um, less than one ACH 50, will bath fans work, or should you be exhausting from baths with ERV only? Um, you would really want to use an ERV for that. Um, at that point, you will be negatively pressurizing your house. And even though bath fans aren't a huge flow, um, they are going to kind of be pulling air through your envelope, around windows especially is kind of the path of least resistance a lot of the time. Um, one ACH, it might be more like, maybe a wire going through or something like that. You probably don't have that many leaks. Um, but your bath fans will work. Um, they just might not work great. Um, so I would recommend using an ERB for that. So I'm not familiar with Brian. There's apparently they're using a Brian AI 160. Um, I'm not super familiar with that manufacturer, but Brone, sorry. Um, if they allow you to do bath exhaust, then absolutely I would do it with your ERV. Cost of filters is usually not terrible. 40 to 60 bucks, depending on the unit. Um, I think that's it. Okay. So now we'll go on to Central. We'll have a couple more questions tabs too, if I missed you. So we'll start with central systems. Um, Central ventilation accomplishes those goals using one central unit. So that's why we would call it central. It distributes air across the structure using ductwork. So these units tend to be fairly feature rich. They usually will already incorporate a filter. Sometimes they have higher level filtration options available as well. Um, there are a lot of different ways that you can design ducting for central units. Um, the unit in the render here is one that from a manufacturer that uses kind of bespoke ventilation or bespoke ducting that they produce. They design all of the components for their distribution. Um, and so they're using a manifold system in this case, where they have a duct silencer taking the air that's being moved around via these larger diameter ducts, um, and breaking it into a bunch of smaller 3-inch ducts so that it's easier to get through framing and through the house, and then going out to the rooms. Um, there are also a lot of different methods that manufacturers implement. They'll tell you what they want you to use. Some will want you to use sheet metal. The main takeaway there is if a manufacturer is telling you, hey, use this size, use this material, you should use it. Um, these units do tend to be kind of sensitive to duct sizing. We'll get to that in a little bit. The other takeaway here is that this could take up a lot of room. In this specific case, this unit's going to have 40 of those little 3-inch ducts. The render leaves a lot of them out, just for the sake of visibility here. Um, but you'd have a lot of ducts running through your house. You have fairly large amount of space taken up by these 4 manifold boxes. Um, so you can see how important planning is going to be for successfully implementing this. They've got a lot of advantages, but you really need to think ahead and make sure you've got space allocated for them, space allocated for the ducting, um, and make sure you're thinking about that stuff. So the kind of the single biggest advantage to these central systems is that you have really fine control of how much of your air is going places and where it's going. Um, right. So there was a question about the bath fans there. Um, so if you're adequately ventilating them and that ventilation is continuous, I absolutely would do it with an ERV. It's gonna give you a little bit better thermal performance, but it's also gonna manage the air quality in those bathrooms better than a bath fan would. We saw how the bath fan, it wasn't doing a whole lot for the air quality in that room, even though it was pulling air out, because it's not diluting anything, and it wasn't on to begin with to prevent that buildup. You saw how it slowed everything down, but it didn't prevent it. When you have a continuous system like this, even at that 20 CFM, right, it's working probably 5 times as much air on, it's moving probably 5 times the volume of air as a bath fan, an intermittent fan, even if that intermittent fan is 80 or 100 CFM. Just by virtue of this system running 24 hours a day in the background, it's going to manage moisture better. It's going to manage odors better, um, and it's also going to be quiet. So generally, especially if you have like silencers like this, you don't hear it relative to a bath fan that you know your bath fan is on. Sometimes that is a little bit of an adjustment for people. So it's something to bear in mind if you are doing designs. Sometimes people like the fan noise. I've gotten that comment before. Um, you probably won't be able to hear this, which is kind of the idea, but it's something to be aware of. So central units are probably the most common systems out there. They're usually aimed at single family projects that have a little bit more complexity to them, or they have really strict requirements. They can be really simple. They can be very feature rich. They can be big. They can be small. There's a lot of options out there. Usually there's a size that will work for your project. Um, and again, really what we want from this is a continuous balanced unit. Again, ideally one that'll self-balance. Um, I mentioned that those ducting systems can vary by manufacturers. Um, so those manifold systems, there's a couple of them that will use those. Those can be really nice. They can be a little bit more flexible. Most notably, Zender will use those. I think Brink uses those. Um, if you have space constraints, as weird as it sounds, it can sometimes be a little bit better to have a bunch of these little 3-inch ducts that can run through a 2x4 relative to, a 4 or 5 inch round that won't. Um, so I'm going to say the word planning about 100 times while we talk about central systems. It's really important. Um, Again, they're very sensitive to the quality of your installation. They're very sensitive to making sure you're sizing things right. And that's because they don't move a ton of air. They don't tolerate a lot of static pressure, particularly if your occupancy permit is going to depend on you having those bathrooms hit a number. Um, you need to make sure that you're not, making 90-degree turns across a 70-foot run just to get to that bathroom. Um, so it helps so much to think about this from the beginning, which we really should be doing anyway. But particularly if you're looking at a central system, thinking about it from the beginning and trying to allocate room, think of ways to sort of hide ducting, um, and get it to where it needs to be. That's going to go a long way for successfully implementing a central system because it's not just a box that we're checking, right? We've gone over all the reasons we want this to work well. It's a really important thing. And a lot of the time, unfortunately, it gets treated more like a code compliance, like this is my inspector says I have to. We are actually, there's some very tangible benefits to doing this right. And when you plan it from the beginning, it's a lot easier to do right. So on the note of installation quality, and I'm really sorry about this, but these do not integrate well with air handlers. Yes, I know there are many HRV manufacturers who have approved implementations, right? I've seen they've got the install manuals that show you how to put them in with an air handler. Those same manufacturers will also tell you almost always there's a better way. We would rather that you have standalone ventilation. You can do this if you need to. Um, it's preferable to have them stand alone. And that's because air handlers move kind of a ridiculous amount of air because air is not very good at moving conditioning. It happens to be free and abundant, so we use it. Um, but the ventilation rates that you need to breathe are comparably very low, usually like 100 to 200, sometimes more, but in that range, right, 100 to 200 CFM, relative to an air handler that's moving between 1,000 and 2,500 CFM on average. Um, the ducting, as you might imagine, has to be a lot bigger for an air handler than it does for an HRV, and it's not something that you can mix. It's really hard for an HRV designed for 120 CFM to deliver appropriate airflow to your rooms through an 18-inch round or a 10-inch round or whatever. And similarly, HRVs are not good air handlers. They won't reliably heat or cool a house that's got a load greater than a few thousand BTUs. If you've got a passive house and you just want a little bit of supplemental, you could use an HRV. I still probably wouldn't. It would be cheaper and easier just to have a mini split or have something else do that and let them be separate and not have to worry about how their interdependencies work and um, trying to troubleshoot stuff. I probably wouldn't. And that's in that really fringe case where you want supplemental cooling for a passive house, right? For everybody else, just don't do it. Again, this kind of gets back to like can and should are not the same thing. Um, don't do all the work and get less. And I live in a house with bad ventilation and a forced air system, right? If this worked well, I would be all over it. Just trust me on this one. Don't do this. Um, so again, back to planning. Let's look at a little bit of design, and how you might go about designing a central system, or things to consider when you are designing a central system. So um, it's not that complicated to plan for them. The nice thing about air is that as long as it has a place to go, nothing explodes. You don't have really serious issues. As long as it has a place to go and you have a condensate management system, um, we'll get to that. Um, Central systems can be really unobtrusive if you have the right components and good design. So if you have a simpler system that has no duct silencers in it, I mentioned that with the bath fans, you might be able to hear those fans running. It's not going to be loud, but it is going to be there. And these run continuously. So you're kind of going to have that background noise. Usually when you hear people saying HRVs are noisy, I don't want that because they're loud. This is the culprit, is that there's no sound attenuation in the system. Um, if you have duct silencers, right? If you have either one of these boxes or they are available in other form factors as well. Sometimes folks will use ones that are available for HVAC systems. As long as they're sized right, it's okay. Um, but if you have those, it's basically a box in the closet, right? And you forget that it exists until you wonder when the last time you changed the filters was. Um, so having the space to put stuff in and using those components, like silencers and just making sure you're considering those factors makes this really, really easy to live with. Um, Now, on the note of space for your unit, when you plan a unit location, plan to have it somewhere that's accessible. They do have filters. You do have to change those filters, just like everything else that has a filter. If you don't change them, your fans will break. And the further under a crawl space, up a ladder, over a rainbow in another dimension that unit is, the less likely those filters are to get changed. It's an exponential thing. I see it all the time. The harder it is to change filters, the way, way, way less likely somebody is to do it. Even if it's just, in a corner of the house that nobody ever goes to, out of sight, out of mind. Um, you know, Usually they'll take up a space that's roughly closet sized. Some are smaller, some are larger. But if you have a spot in a laundry room, there's a spare closet somewhere, anywhere that you have like a roughly 3 foot square, maybe 6 foot tall space to hide something away, and you can run a drain to it, that is a better place to put it if you can. It doesn't have to be a mechanical room, despite what my little duct tyrant down here says. But you do want a mechanical in a room. Um, this is also a really big concern for people who are aging in place. Just as kind of an aside, a lot of folks who are building new construction are looking at a retirement home, a forever home, a place that they're gonna get older in. Um, and just because they can get to it now does not mean that they'll be able to get to it later. My mom is 75. 3 years ago, it was kind of laughable to think about her using a walker. Now I just went to Maryland. I just got back from kind of having her come live with me because she's falling down a lot. Her balance is really off, right, over the course of 3 years. Um, so stuff does change and that sucks, but you don't want to have a situation where somebody who previously could change all of their filters now is kind of neglecting their maintenance because it's dangerous for them or it's hard for them. And then you have mechanical problems with their units, which then lead to air quality problems in the house. Just put it somewhere people can reach. Um, don't put them in crawl spaces. Please never put one of these in a crawl space. I see, I see that too. Don't do it. Don't make people crawl under their house to get to their unit and change their filters. Just don't. Um, Attics are okay-ish. Again, it's not great for that aging in place thing, but just plan on having it somewhere that people can get to it. I really can't stress that enough. Um, so drains, I mentioned a couple times. Heat exchangers are functionally a large condensing surface. You need a drain. Wherever you plan on putting the unit, plan on running a drain line. Um, it's nothing huge. It's not gallons of condensate, but they do produce it, right? And it does need to be managed. That is true of HRVs. It is also true of ERVs. There's kind of conventional wisdom, quote unquote, floating around that ERVs don't need drains. Um, I disagree. I have seen many ERVs that needed some very expensive repairs because they didn't have a drain. Um, your manufacturer might say, no, you don't need one. Again, can and should, not the same thing. It's super cheap insurance. Just put a drain on it, HRV or ERV, and you'll be fine. So we need room for our ducting too, right? And this is another thing where early planning is really key to success with these. It just helps so much. Um, right? Drop a ceiling, build a chase, right? Find a way to hide stuff, whatever you want to do. The earlier you start thinking about this stuff, the better. I get a call maybe once a week, sometimes of the year it's like once a day from some poor, very tired HVAC guy who just got to the job site for the first time and realized that it's, you know, the unit's on one side of a 70-foot long rambler with vaulted ceilings all the way through and a slab on grade. There's nothing. There is nowhere for ducks to go. They don't want to build a soffit for him, right? And if that's the case, this isn't going to work. You need some sort of room to move these ducks around to get them pulled through your house. So just think about that a little bit ahead of time if you're wanting a central system, um, and you'll avoid that whole issue, right? You just have to find rooms. Bathrooms are really easy to drop a ceiling in. People don't really look at bathroom ceilings that much. Usually they're not vaulted, um, but that just stops your duct plan from being made by somebody who just put their boots on the ground for the first time and is planning on doing this all in 2 or 3 days. Um, it will help you make sure that your install goes a lot better. And if you send me a drawing with ducting on it, right? If you send me a ducting plan that you have drawn on your architectural plans, you will get all the gold stars. I will love you forever. Maybe I'll have some notes, but we'll figure it out, and your system will get installed right because it wasn't planned on site by a guy who just got there. Um, I have that air schedule here again from the system design example. And so that's also something, of course, you would want to work up ahead of time. Some manufacturers will actually do this for you. That's an air schedule from a Zender design that Zender did. Um, but you want this both as kind of a guideline for your installation to tell you, maybe what size duct you need to go where, or if you have a manifold system, how many ducts need to go where. Um, but also, this is going to help you with your commissioning. Um, it just gives you a nice little template to go around to measure stuff, to verify against. Having this ahead of time instead of figuring it out on site gets you better results. As a final note for the central side of things, if you're the designer, right, again, pay special attention to that duct sizing. I just can't say it enough. Don't use trunk and branch systems, um, right? Make sure you're using the right size, but also trunk and branch are kind of a go-to for a lot of people because we use them a lot with air handlers. Air handlers can deal with static pressure. Um, Trunk and branch systems work off of static pressure. So static pressure is really our enemy with HRV systems. Um, you're not going to have enough, or you don't want to have enough in your system to where you can force air out of a duct that's just coming 90 degrees out of your main trunk. Um, if you wanted to go with like a branching system like that, I would really recommend running like or considering, Y connections, or like the pair of pants ducts are my favorite, where, instead of coming off at that 90, or even, maybe having a 45 coming off, um, you have sort of a wedge where it splits. And at that point, you're not relying on any sort of static. It's just air moving as air moves and getting split by that little Y in the middle. So overall, central systems are powerful. They tend to be the best choice for larger projects, where you'd need a lot of really small decentral units. Decentral units tend to be smaller. Um, so if you have a larger project, you can do it all in one. They give you a really good opportunity to have high level filtration for your whole house, especially if they're your only source of air ingress, right? And they also tend to be pretty not annoying, provided you've put in the right components. And that the whole goal with Central is that it's just kind of invisible, right? You don't notice it; it's just there working in the background. Um, the challenges for a central system is it's space, right? Space is the big one. You need to run ductwork. You need to do a good job running that ductwork. Costs tend to be higher because of that. Um, it's a really good idea to do some planning and design work for a central system if your manufacturer won't do the design work for you. Um, and that planning can be a little bit more involved. So the kind of the two challenges here are you need to think about it a little bit harder, and um, you need room, and I guess they can be a little bit more expensive in terms of overall system and labor. Um, Generally, I would point you at a central system over a decentral system for projects that are, maybe larger than 1,800 to 2,000 square feet. Unit sizing just becomes kind of challenging at that point. It gets a little more cost effective to go with one main unit instead of a bunch of smaller units. You also don't have to buy a bunch of filters for those smaller units. You don't have a bunch of fans. The more units you have, the more potential for issues you have. Um, so once we get past about 3 decentral units, that's kind of the point where I'm like, okay, you should probably, if you can, maybe look at getting a central system for this, um, because it's going to end up being a little bit more practical. Um, New construction, I will also generally recommend central systems for, especially if it's single family, just a house like this, because the obstacles you have to your installation aren't nearly as onerous when you're building it. If you don't have your sheetrock up, then most of the problems are not there. Most of the challenges are not there. You just have to drill holes. You have to find places to route it. Um, it tends to be a lot easier when you don't have sheetrock up versus something like a retrofit. If you're doing a really deep retrofit and you are going down to your studs, especially for like a deep energy thing, same thing, right? If you don't have your sheetrock up, go for it. I do not have an issue with people putting in central systems, um, if it's easy for them and that's what they want. Um, Finally, people who have really serious allergies, talked about that a little bit. You really need to mitigate your air ingress, right? You really need to control finely, um, that air movement and your air quality. It's easy to get pretty good air quality with a decentral system. It is really hard to get that kind of fine control with them. So if you have pretty serious sensitivities, central is probably the way to go for you. Let's see, questions about central. HVAC ducting for return HRV only. Um, it's tough. It really depends on the system. Um, I I tend to recommend against it. Um, it's just a lot easier to get what you want from them when you aren't trying to sort of bootstrap it to something that it wasn't meant to be connected to, if that makes sense. Especially a return duct for an HVAC system is going to be huge. You might basically what you would do is kind of divert it, right? You'd have sort of like a little diverter in your HVAC duct. Um, and you'd only be moving a small portion of it back into your HRV. Um, it just gets kind of wonky, and I tend to recommend against it. Um, for smaller square footage homes, are decentral better than central re-equipment space needs and air movement needs? Yes. So I will talk about that in a second. We're about to do decentral, but yeah, they really can be. There's not a problem putting a central unit in a smaller project, but decentral can be a little bit easier to work with in those cases. Square foot rules of thumb, sort of. So again, there just becomes a point of diminishing returns past, maybe that 2,000 square foot mark where you're going to need too many, so many decentral units that it's sort of impractical. Sometimes your floor plans get a little bit more complicated. Um, for smaller projects, I really don't see them that much. Um, Usually you can kind of do either, decentral being a little bit more flexible, but not quite as intensive. Installer suggested dumping the supply air into existing ducting for my medium static ducted mini split. Exhausts for the ERV or standalone. Supply air should move through the ducts. Uh, so even when the ducted mini split blower is not running. So again, that gets to an actual delivery, right? Your unit's not going to end up with like a pressure error or an imbalance error. The unit's still going to have the volume moving through it. The question is it going to get to where you want it to go enough? Are you going to get the proper flows out of those diffusers? Um, when you have big ducts like that, it gets hard for the air to go, all the way across your house, um, to end up getting the supply airflow that you want. Um, it really is case by case, but again, I tend to recommend against it. Um, so I think that's everything for Central. So we'll move on to decentral. Decentral systems are a little different. Um, they're not new. They're definitely not implemented as much. Um, and I think that's kind of a shame because they're really good in a lot of really common situations. And as you might expect, the difference between a central and a decentral system is the distribution. A central unit has ducting, a decentral system doesn't. Um, at least usually it doesn't. So that means we can't do some of the things we can with the central system, right? Most decentral systems don't have a way to pull from wet rooms or bathrooms, for example. Or at least you wouldn't really want to, especially in like the pictures here. These are transfer ducts over these doors on the left, right? So basically you would be relying on, um, pulling air out of your bathroom and putting it into your living space, putting it closer to the unit on the wall. Um, I wouldn't recommend it. Um, so that can be a little bit challenging with decentral systems. But where they really shine are those small, like the question we got was, they really shine in small open projects, multifamily buildings, condos, ADUs, small single family, and small doesn't even mean it doesn't mean tiny. Um, Less than 1,800 square feet is more than most people need, whether or not we actually build those. Um, And so they work really well in a lot of situations. And they've got some other nice attributes as well. So looking first at a design for a more conventional single family, right? And forgive my Microsoft Paint CAD here. We'll get into something a little more professionally-ish looking, still drawn by me, but better on the next slide. I did this in Paint intentionally, and I'll talk about that in a minute. Um, but so if we look at our house plan here, this is a really weird house plan. I stole this from Wikipedia. I just needed to have something to draw on. Um, but this is a pretty normal single family home, right? This is probably something that you would run into if you had like an existing construction you were trying to retrofit. Um, and what I wanted to really highlight with Decentral is right, maybe you aren't going for a passive house. Maybe you bought this is your house, right? And you recently switched to a mini split based system that does not introduce any sort of air into your envelope. Um, and all of a sudden you're noticing that your house has some air quality issues, right? And you don't want to do like a deep energy retrofit. You don't want to tear out all your sheetrock. Um, you just want to have good air quality. Um, so as silly as it might seem, right? This is more or less how air moves, and this is something that a homeowner could totally do if they were trying to figure out how to solve this problem. That's why I did this in Paint, right? Maybe you're handy and you can draw your house in SketchUp, or maybe you just have access to plans. Um, you can totally go through and figure out how the air is moving around in your house. You can figure out how to move stuff around with pressure gradients. Um, and one of the really nice thing about Decentral for retrofits is that it plays kind of nicely in what you might call like a hybrid system. So here we've got our main unit in this little purple rectangle, and then we've got an existing bath fan. There's a range hood over here. These aren't doors, they're just kind of pass-throughs where these little blue arrows are going. Um, and then we have a powered transfer fan that we've retrofitted that pulls out of bedroom 2 and moves it into the dining room, right? So a homeowner can kind of look at the situation they have and figure this out, or if you're the installing contractor, you can look around and figure out um, where you would want air to be moving, what paths that air is going to take, and what infrastructure already exists to help out with that. I would probably recommend moving this bath fan. And if you're in California, you already have this, but um, if that's not a humidistat fan, I would recommend replacing it with one and making sure that it's a good one. A lot of the times those humidistat fans aren't great. Um, but then you have a little bit of sensor driven moisture control in that bathroom that's also helping us pull air sort of through the house. Ceiling fans can work really well. A lot of people already have them. They kind of help mix stuff up, move things around. Again, we have a little bit less direct control, right? This isn't what I would look at if I wanted really fine control. Um, but this is good enough, right? And it's way better than ripping out all of your sheetrock to solve a you know, not the biggest problem on earth, but a problem. Um, so that transfer fan and a lot of decentral systems are sensor driven. Um, some of them are continuous, but sensor driven is a really nice option for them as well, because again, those are a little more oriented towards kind of like spot ventilation, maybe you would call it, um, where you have an area of concern and you're trying to address that concern as it comes up. You can use them continuously. I don't want to say spot ventilation like that's a bad thing. Um, it doesn't quite have the advantages of a central system or a continuous system. Um, but it will still get us fresh air. It will still manage that air quality. Um, and sensor driven stuff can be kind of nice and that it's not going to be kicking on it or be on all the time in the background. It's just going to kick on when you need it. Um, but here we have this transfer fan sensing buildups of contaminants in bedroom 2 and exhausting it into our dining room, which is adjacent to the living room where our main unit is. That main unit in this example is also sensor driven. It will pick up that buildup from that bedroom 2 that's being exhausted into this sort of combined space and do an exchange on it. Um, the other one that is a fairly common setup, a lot of people are familiar with, is Lunos. I don't have a ton of direct experience with Lunos, but basically what you would see here is you'd have this purple unit here still. You would have another one maybe over here in bedroom 1. They would be paired together, and they would actually go back and forth. They would switch directions. So you'd have an extract, and then they would switch directions, and they'd have a supply. Um, I'm not crazy about that system, but it does work. A lot of people have used it. Again, it's just something that um, you want to make sure you know the parameters. You want to make sure you know operating noise, and make sure you're putting them somewhere that um, it's not going to be obtrusive. Um, but when we look at this, right, is it a perfect setup? No. Could we get a little bit finer control of the central system? Yeah, right. But it's good enough. This solves a problem. It's budget friendly. And if this is the bottom floor, you can see there's stairs here on the left. If we put a similar system up on that top floor, right, even if this is, 2,000 square foot house, we've got whole house ventilation. Uh, these are really, really good for retrofits. They, as I said, they play pretty nicely with stuff that's already in place. It's not going to play nicely with that range hood. It's not going to be big enough to make that up. Hopefully you would have something to accommodate that. But the bath fans, they can kind of work together. Um, so a lot of people, myself included, it's not really in the cards to yoink out all the sheetrock and throw in a central system. And that is going to bring me to my basement. Um, Part of it anyway. So I wanted to look at this because the other really nice thing you can do with decentral systems, and again, getting back to that flexibility, right, is we can use them for a partial ventilation. So that previous example would have been a whole house, but well, let's look at my basement, right? So my house is a real cobbler's kids situation. This room is the worst offender. I hate this room. I have hated it since I moved in. Otherwise it's okay, right? The house is okay. It's not great. It's fine. This room is a blight. You probably would not have such strong feelings about your den, but I do ventilation for a living. And while my mom is staying with us, my wife and I are living down here. Um, it mocks me every day. Um, It is a case study for what happens when you do things wrong, and not a malicious wrong, right? It's not egregious, but somebody did something not great 15 years ago, and now I have some expensive problems. Um, if this room had been ventilated appropriately from the beginning, this room would probably be fine. I wouldn't have the issues that I'm having. I'm not saying you should use ventilation as a band-aid, but absolutely it would have mitigated this issue before I had an expensive problem, and I'm going to put it in now to manage this. Um, so living down here has kind of been the last straw for me. Let's go through my plan for my actual house, right? And hopefully this gives you something you can pull out if you or a client has some similar issues, right? So the problem in this room, which is actually 2 rooms, is moisture buildup, right? And then in the case of that back office space here, zero ventilation. I've looked high and low. There's no vents. There's no registers in there. There's one right outside of it. I have a forced air system. There's nothing in that room. Um, right. And so this is kind of the really handy use case for some of these systems is you don't have to do your whole house. You can partially ventilate in problem areas. That's something that comes up all the time when people call me. Um, and it's something I'm going to do, right? I have a forced air system. I'm not in love with it. Not great at moving air around or ventilating. Um, not great. Doesn't make my heat bills feel good. Um, but I do have something that moves air in the rest of the house for it to not get too bad. Down here, it gets too bad. Um, then eventually I'll move to a heat pump based system. At that point, maybe I'll look at a central. Um, but right now, kind of my big challenge here is that my electrical panel is way, way off on the far side of my garage. And there's a slab right there that I can't run through. There's no interior walls that connect. Um, it would be pretty difficult to route ducting around. Um, it's just something that I don't want to deal with right now. But the moisture buildup in this room, which is about a fifth of my house, um, is starting to cause issues with my floor joists above, which is my living room. Right, so much moisture is building up in here that my joists are warping. My floor is really springy. I'm starting to have some house durability issues because this basement didn't get finished very well. It's just carpet on a slab. There's not a whole lot of moisture control, and again, there's not any ventilation down here. The central return for my air handler is not anywhere close to this room, and air is not getting pulled out of it. So I'm starting to have that trampoline floor up above it, um, which is gonna be just a giant pain to deal with. Um, and then my wife is using this back office area, or she wants to use it. She's already got her desk down there. She's already kind of moved her stuff in there, but she doesn't sit back there much because there's no ventilation. It gets really stuffy. It's not super fun to be back there. Um, and so what I've settled on here is very similar to what we saw before, just scaled down. Right. So this is about 400 square feet. Gets used as a bedroom sometimes. I've had friends living down here. I'm currently using it as a two-person bedroom. So generally, I would have about 30 or 40 CFM in there. And I didn't pick this example just to complain about my house. Um, it's also important to note that, if you imagine this space with a kitchen in it and a bathroom, this is an ADU, right? Or a small single or a small multifamily, right? An apartment, a mother-in-law, whatever you want to call it, any sort of small standalone dwelling, this is a pretty decent analog for. Um, what I'm gonna do is put in a small little sensor-driven decentral HRV in my wall. So that bottom right corner there, next to my window, kind of in that corner. And it's always going to run at a low level, but because it's sensor driven, it's going to really help manage the humidity that's in that space, and the CO2 when it's occupied. It's going to notice those levels build up and do an exchange. Similarly, I've got one of those transfer fans back here in the office. That's going to be sensor driven, but it's going to be one way. So that's going to pull air out of the office and exhaust it into this larger space, pulling fresh air from this larger space under the door. And they're both 110 units, right? So I don't have to pull power for them. I don't have to pull a 230. I don't have to mess with my panel. I could just literally plug them into the wall if I wanted to. And so 3 holes drilled, right? And no ducts. I'm gonna solve this problem. I will have a way to manage the air quality issues in this space uh, really, really easily, really, really quickly. And if this was new construction for like an ADU or Um, it was a space that didn't have a critical issue with the floor above it, right? Even in that situation, uh, we could prevent that situation very, very easily just by putting something in that it's not doing the whole thing, right? It's not if maybe the rest of the house doesn't have this issue, but we can spot ventilate here very, very easily and fix this problem. As it is, I still have a floor to fix, but at least I won't have this clammy hellhole that I hate anymore. And again, this is a case that people call me about all the time. So if you do run into like a hotspot problem, um, something like a partial ventilation project, it's decentral all the way. It's so much easier. So decentral is a fantastic tool, right? It's also not central. It can be just as efficient. So I didn't talk too much about SRE with either of them or other efficiency metrics. That's just because it varies a lot. You know, not all units are built the same. You can have really inefficient ones. You can have really efficient ones. It just depends on your equipment selection. Um, both of them are going to have pretty low power draws. Really, the difference between the two comes down to the use cases. And I kind of think about them as like different pairs of pliers for reference, right? You know, if you have a pair of vice grips and you have a pair of needle noses, you can do some of the same things with them. You're not going to use them for all the same jobs. Decentral is flexible, it's simple. A homeowner can figure it out. They can do a ventilation plan. We could do spot ventilation. We could do a standalone whole house system. You can do a hybrid system. Um, and it's really nice for small new. It's really, really nice for retrofits. It can be a lot easier on the budget, and it can still provide really high level filtration. Generally your central, or the HRV unit itself will have still a fairly high level filter in it. The main reason I recommend it against them for people with sensitivities is that you probably are going to have stuff like bath fans or things like that with these that may introduce some air leakage in your envelope. Um, but they're simple, they're flexible, they're just really, really nice for normal. I don't want to say normal projects, but people who maybe do are not as concerned about the things that you would want out of a central system. Um, they're not great for being the only thing moving air in those larger projects, especially if you have more complicated floor plans with a lot of interior walls. You really need to think about how that air is moving around in those cases. And we saw how much door being closed impacts how that air moves. Um, you would want a lot of transfer ducts or a lot of transfer fans in that case. Those transfer ducts can allow noise through, which sometimes people don't like. Um, you might just want to go with a central system if you have one of those larger, more complicated floor plans. Um, they usually don't do bathrooms. Some of them do. You have to know what your manufacturer has. There are a couple of decentral units that have the option of putting a duct on the back of it and running that out and turning it into sort of like a little mini central system where you've got, an extract register in a bathroom, but then the unit itself is the place where air is getting supplied. Um, they can be flexible in that regard. Most of them don't do that. Um, so generally speaking, I would say they don't do bathrooms. Um, they're usually pretty quiet, but the most sensible place to put a decentral unit is gonna be like a living room. So they're not quite as invisible, right? They're gonna be there, and you probably will notice it. It's not gonna be super annoying. Your fridge is probably gonna be louder, but it'll be there. Um, it's not quite the same hide it in the closet thing. So to kind of put a bow on it, they're similar but different tools with a little bit of overlap, right? So for large projects, you almost certainly want a central system. Um, For projects that have really strict requirements regarding that air quality, regarding your infiltration, regarding how you're handling bathrooms, um, you'd probably want to go with a central system. Generally speaking, if you can, I would usually recommend them for new construction, unless you have a really simple floor plan. ADUs, multifamily, it's different, but if you're building a relatively normal looking, 1,500 square foot house, and you're doing it from the ground up, then you can probably do a central system and not have to put bath fans in it, or um, get a little bit finer control of things, maybe have options for a little bit higher level filtration, like, carbon filters, particularly, usually are not available with decentral units. That's what you would use for like wood smoke, stuff like that. Um, so if you're building it from the ground up, you might consider going with the central system, even if it's going to cost you a little bit more. Um, it might just be a little bit nicer to live with. Um, so for decentral, uh, I'd usually recommend over central in almost all retrofits. Right? And that's just about always it's for practical reasons, right? So take my house, I work for the Zender distributor. Absolutely, I want a Q450 in my house. Um, there's just no way, I'm not gonna put that in at the moment. Um, I don't want to put it in my air handler because it's not gonna work great. Um, if you are prepared to take that on, I'm not saying don't, but most people don't want to do that, myself included. And so, for retrofits, my go-to is a decentral system. It's not going to be invasive. It's 3 holes, you drill, or however many, 2 holes for the unit, and then however many transfer fans or transfer ducts you want to put in. Um, it's so much simpler, so much easier, um, so much less invasive, labor intensive. And usually those units are going to be 110, so you don't have to do a ton of wiring. There's nothing crazy. Spot ventilation, decentral all the way, right? Again, so much easier. Um, it's just pick a place for the unit, maybe an adjoining room connection or two, done. Um, Homeowner-led projects are you know good for decentral. If you were a DIYer, right, and get your permits, all the legal disclaimers, etc. But this is probably a little bit more accessible for people who are wanting to work on their own project, wanting to do it themselves. Simple does not mean easy, um, right? So not not quite easy, I wouldn't call it. But if you're pretty handy and you have some experience, you know, and you wanted to do it right relative to hiring somebody to put in a central system, decentral is really nice for that. That last one for decentral is kind of jokey, right? I don't know how to say this exactly. I did say it a little bit earlier, but sometimes uh, you just want it to be good enough, right? It doesn't have to be perfect. It doesn't have to win a medal. I have an air quality problem and I want it to get fixed. Um, Decentral is really good for that. It's a nice flexible system. Maybe it's not quite as powerful, but it solves the problem and it does it efficiently. It follows the principles we talked about when we talked about our ventilation basics, and it gets it done, right? And it's good enough. In the middle, we kind of have, everything else, right? If you're not firmly excluded from one of those categories, you can kind of do whatever you prefer, right? Central is a little bit more refined. It tends to be a little bit more feature rich. You can do some cooler stuff with it. You can do some more complicated stuff with it. Um, Decentral is really flexible in terms of where you put it in. It's really flexible in terms of what it's doing. If your project isn't dictating which one is best for you, just sort of, yelling at you, you should put in a decentral, you should put in a central, right? If your project isn't dictating that, you can pick, and you're not going to be wrong. You just want to, one will probably give you more of what you want than the other. And that about does it for me. What kind of questions do we have? There's a few. I got to find where I was here. What are your thoughts on a remodel swapping out bath fans for decentralized Panasonic ERVs? 2,000 square foot house, 3 baths, and a laundry. So that is kind of the exception to what I was talking about. And I didn't bring this up, but I'm glad you did. That's something that you can do if your units are rated for it. So I don't know specifically about the Panasonics. I do know that Zender's CA70 is rated to be installed in a bathroom if you wanted to. So you could use it as your bathroom exhaust. You could put your unit in there. And it works really well. What you run into there is that you want to, in that case, you may want to run one of those supply ducts right out where you've got a duct coming off of the unit, or find a way otherwise to distribute your supply air. Because if you don't, then you do have your bathroom mitigated, um, but you're not getting a whole lot of air movement outside of your bathroom unless you leave your bathroom door open all the time, um, which you could do. But yeah, absolutely, that's a thing you can do. Um, it would probably be expensive if you're just, if you're just replacing a bath fan with an ERV and that's the rest of your house is taken care of. It's going to be more expensive, but it will work. Let's see. Do you have recommended resources to calculate ERV CFMs? Yeah. Typically what we'll do is a whole house calculation. So there's a standard that is kind of used. It's the ASHRAE standard, which is copied and pasted by just about every code agency out there. It's called 62.2, and it's an equation. So basically, you take 3% of your floor area, and then you add your number of bedrooms plus one, and they do plus one because usually you have two people in your master bedroom. You multiply that number of bedrooms plus one times 7.5. You add that 3% of your floor area and whatever you got for your bedrooms together. That's your total house ventilation requirement. It tends to be a little bit low. I usually bump it up like 10, 15 CFM. But that's kind of ballpark for what you want for the entire house. And then you can kind of go through your house plans and go, okay, I have 1, 2, 3 bathrooms. I will need a minimum of 20 CFM in each of those bathrooms. Maybe you want it to be 22 or 24, right? Something in that area. Um, and so you can start penciling in, I want 20 CFM in all my bathrooms. I want 10 CFM in my laundry room because it's not going to be quite as much of a moisture concern, but I am going to want to pull air out of there. Then you can look at your bedrooms, right? I want, maybe 15 to 20 CFM per person. So I'll put, 15 or 18 in a kid's room. I'll put 30 in the master bedroom. And you can kind of go through and pencil in until you get to that number that you had calculated for your whole house. So hopefully that helps. Thoughts on using Zender tubing and diffusers with a lower cost unit? That works. Maybe I shouldn't say that. I don't know. I work for the Zender distributor, but it does work. I have people who do it. Life Breath. I have a couple of people who do it with Life Breaths. It's fantastic. The distribution is the best part of the Zenders. Their units are really fantastic too. They're really feature rich. That distribution is just, it's so nice. So that absolutely works. Just be prepared to figure out, well, let me back up. It absolutely works if your unit is okay with that. I do kind of have to defer to manufacturer specifications. I have not run into a whole lot of units that are incompatible with it. But the main caveat there is that you would probably need to figure it out yourself. You would need to figure out how to adapt to it. Um, but yeah, I have people who do that, and it does work. What is the smallest ERV system available today? Probably the CA70. It's about 22 CFM normally, which would be a bathroom and maybe a bedroom. Really, really small project. You, depending on your jurisdiction, might not actually be able to use that on its own. Um, Sometimes they will have a minimum of like 30 CFM for the whole house, um, which it would not be great for. But those little 70s are phenomenal little units, either for partial ventilation or for like tiny houses or really, really small projects. Uh, California Building Code uses amended ASHRAE 62.2. Oh, that's good to know. Okay. So California has a little bit of a different calculation for your total ventilation rates. Let's see. Anybody else in here? It looks like that's all the questions. And I think I even made it on time. No, I'm over my time. I'm sorry. But I got close. Run my mouth a little too much. But um, yeah, thank you guys so much for being here. And I'll go back over to Itzel for our closing.
Thank you for a great presentation. Yeah, before we wrap up very quickly, if you have any questions regarding AI learning units, feel free to email me. I'll drop my email on the chat. And coming to you, we have slides in the recording and a survey. And just some upcoming courses. So we encourage you all to check out our calendar. We have some new classes listed on there for the new year. Um, yeah, and with that, thank you so much, and we'll see you all very soon.
Thanks, everybody. Have a good day.